Hello, my name is Abdul Latif Waja. So today I'm going to present for the next video assessment, which is video number 2 for my FYP2. So let's start. So this is the overview which I will going to present today. First, I'll talk about my progress so far, and then I'll move forward towards the brief. I will briefly tell you about the overview on the equipment which I'm going to use and what are the purpose of that, and then the project planning at the end. So let's start. First, I'll start with progress. So far, I have had in my thesis, I have had 35 references, although we had the minimum limit is 30, but I have exceeded already. I hope there won't be any problem with that, but because I had to write a lot, and then my equipment has arrived. Soon I will start my experiment, and then the final I have to say, like, I'm in the final phase of the project, which hopefully I will complete on time. Now we'll talk about overview on my equipment. So in this part I will talk about what equipment I will be using, and I will describe role of each equipment. So first I will talk about temperature and humidity sensor. This system uses a sensor that allows retrieving the temperature and humidity via one single device, which is SHT11. Uh, it is well known that there will be strong increasing temperature variation compared to normal temperature weather whenever forest fire occurs, like we have been noticing this in our university. This can be continuously detected and monitored by means of temperature sensors and in accordance with the simple arrangement of transmitter. This concept is quite reliable and cost efficient in forest fire detection, since simple equipment is arranged in a simple configuration. This is the module. This is every module has its own identifier relative to its location on the forest. The power consumption of sensor is very reduced at an average value of 0.55, while measuring and an average current of 28. For communication, sensor uses a standard I2C interface. So next I'll talk about gas sensors. The gas sensor used for this system is need to be capable of sensing the carbon monoxide that composes a major part of the chemical composition of wood smoke. Uh, for detection range, it's deduced from the monoxide danger curve. The curve gives insight about the danger and effects of exposure to CO depending on its concentration in ppm and the exposure time in hours. Next is communication layer. For communication layer, LoRaWAN is the technology of choice, seeing its long range capability and low price modules, which allows interconnections for long range and for long time on battery. The Raspberry server. The server station will be made on Raspberry Pi 3 unit that allows to retrieve all the data from the LoRa network and share it through a graphic user interface and publishing into the external server for further processing and more data availability. To clear about this, I will tell you about like that. The Raspberry Pi connected to the LoRa module will form a LoRa gateway for our project, allowing it to interface with internet network. Assuring the information availability is key point of our system. This will allow more control and visualization, which makes the intervention delay smaller and allow firefighter interventions more efficient. This is why I chose that. I'll talk about sensor node architecture. The sensor nodes are composed of sensors and with a microcontroller and a communication module, which allows retrieving formatting the data for making it easier to be interpreted on server side. Now the server architecture. I'm going to talk about the architecture of server. The server station made of Raspberry Pi 3 unit connected to a LoRa module, like I said before, for interfacing with sensor network, and a GSM module for sending urgent alarm autonomously. So this is be done because if there's an emergency, it will directly give a call or a message to that specific number which we have to specify in our programming part. The server could also be connected to a display for local visualization of the data. So now I'll talk about my project planning, to tell you more, to clear the concept what actually is project will be look like at the end, uh, and what programming language I'm going to use, how I'm going to implement. So to get the concept into realization, the sensor module will be connected to the controller and communication board. The sensor node will be programmed using Arduino IDE. Then for the service side, the LoRa module will be programmed for allowing the data to go through it to the Raspberry server. For Raspberry, it will be programmed using Python language for receiving the information coming from the sensor, and it will act as an interface between the sensors and hardware implemented on field on and the IP domain where data could be collected and available 24/7. The connection to internet will allow us for remotely controlling the system as changing the sampling rate for sensor, allowing power consumption adjustment, or getting the state of a specific node using its ID rather than the possibility of for having more strange space and computation power if it is connected to external servers. So basically that's it for my second video assessment. Thank you for listening. Thank you so much.